Consider the set of points z such that mod z minus 2i is equal to mod z minus 2 plus 3i. Now I would rewrite this. The z minus 2i is fine, but the other part I would write as mod z minus 2 minus 3i. If you think about expanding the bracket, that would give us z minus 2 plus 3i. But writing it in this form means that we're at the point 2, negative 3. So 2, negative 3 is one of the points we want. Z minus 2i is the distance from 0, 2. If z is to be an equal distance from these 2 points, then it needs to be the perpendicular bisector. Now let's think about the gradient of the line I've just drawn. It goes 2 across and 5 down. So the gradient there would be negative 5 over 2. The perpendicular would need to have a gradient of 2/5. And it would go through the midpoint of that line. So we have a line that has endpoints of 0, 2, or line segment 0, 2, and 2, negative 3. So the midpoint there is going to be 0 plus 2 over 2, and 2 add negative 3 over 2, which is at 1, negative 0.5. So the midpoint would be somewhere around here. And a gradient of 2/5 means that if we go 5 units across, we would need to go 2 units up. So that would put that there. And if we went 5 across the other way, we'd need to go 2 down. So a line going through those points there, like so. We now want to determine the Cartesian equation. So we know that the gradient, as discussed, was 2/5. We also know it goes through the point 1, negative 0.5. So y is equal to 2/5 x plus c. Using the point negative 0.5 is 2/5 of 1 plus c, which means that c is going to be negative 1/2, take away 2/5. So that's negative 5 over 10, take away 4 over 10, which is negative 9 over 10. So we've got y is equal to 2/5 x take away 9/10.